Lab 1. Task 1.
In task 1, we do leveling. Leveling is a process of transferring height above a datum from one point to another point. This leveling process is used in engineering to establish building elevations, layout of highways, determination of floodplains, calculate volumes in earth, design and layout of sewage and water lines, develop topographic maps and student cluster earth movements. Benchmark is definite permanent accessible a point of non-height above a datum to which the height of other point can be referred.
Step 1. Setting up.
Setting up. Setting up is backside and foreside distance should be approximately equal to avoid an error due to collimation, diffraction or earth curvature. Distance must not be so great as to not be able to read the graduation accurately. The points to be observed must be below the level of instrument but not lower than the height of the staff.
Step 2. Elimination of parallel.
Elimination of parallel. Parallel is the apparent movement of the image produced by movement of the observer's eye of the eyepiece. It is eliminated by focusing the telescope of infinity and then adjusting the eyepiece until the crosshair appears in sharp focus. The setting will remain constant for a particular observer's eye.
Step 3. Booking.
Booking is level books or loose-leaf labeling sheets shall be numbered and indexed in a register. Detail of the site, work, date, observer, chainman, booker, weather, wind, instrument and any other relevant item shall be entered.
Result for field note from 2 reading, BS and FS.
From doing this labeling work lab, we can get field notes from 2 reading, which is backside and foreside. For the backside in meter, we get 1.34, 1.37, 1.37, 1.29 and 1.59. And for the foreside, we get 1.57, 1.27, 1.45, 1.35 and 1.375. After we get the field notes from 2 reading, which is backside, BS and foreside, FS, we will use rise and fall method calculation, which is value of BS minus value of FS, so that we will get the rise or fall value. For the reduced level, RL, we will start with the 2.0, which is their benchmark. We will minus if the number is fall and add if the number is rise, so that the result is 1.77, 1.87, 1.79, 1.73 and 1.945. After that, we will do checking, which is sum of BS minus sum of FS equals sum of rise minus sum of fall equal to first RL minus final RL, which is 7.015 minus 6.960 equal to 0.315 minus 0.370 equal to 2.00 minus 1.945, and the result is 0.055 equal to 0.055 and equal to 0.055. For the second calculation, we will do height of collimation method calculation for leveling work procedure. So, the 0.055 is the value for checking the leveling work. So, the formula is sum of BS minus sum of FS equal to last RL minus first RL, which is 6.960 minus 7.015 equal to 1.945 minus 2.00. So, the result is 0.055 equal to 0.055. In conclusion, the important thing in this progress is the distance between the 2 points must be accurate in order to prevent from getting the parallax, close, and other major error that can be occurred. Then, we really must use the tools that are related in this technology for collect the data. After that, the objective for this program is we should find and determine the temporary benchmark, and the team must understand the way of getting results and the value. Finally, we can learn and gain knowledge, also the skills in construction site whenever they start as a worker.
Task 2.
In this practical task, we learn about how to determine the area and volume of a site through the tachymetric survey. The cut and fill process is one of the tachymetric survey that provide clear and specific of a land. The current situation of the site should first be taken into consideration while making plans, the design, and earlier than the construction of a building. In most situations, the original site is not always staged and ought to be changed earlier than the construction begins. So, that is where the cut and fill technique adds an important role.
Procedure.
Step 1. Prepare the tools for the lab activities, which is tripod, staff or poles, and rubber. Step 2. Find the place that we can do the leveling to get the value. Step 3. We can start the leveling activities. Step 4. Determine and jot down the value that we got from the leveling. Step 5. After got all the value, we started to the grid method. Step 6. Make the calculation to get benchmark value.
Grid method.
The grid method of calculation involves drawing a grid onto the plan for the earthwork project. For every node of the grid, we set the value and propose flow length and calculate the cut or fill required. Once the cut or fill intensity is calculated, multiply the cost with the depth of using the proportion of the grid cell. Do this for every envelope of the grid, then upload the volume together to decide the general cut and fill volume for the project.
For the grid calculation, the total product is 3.941. So the mean or average for this product is 3.914 divided by 4, which is 0.98525. So for formula for the volume is cross-sectional area of one prism multiplied by mean height of grid, which is V equal to 10 times 10 times 0.98525. So the answer is 98.525 CUM.
In conclusion, by going the grid contour survey, map can be drawn so that one can select most economical or suitable site for construction.
Step 1. Set up tripod.
Set up the tripod on the station, open its leg and regulate the peak so that approximately place chest and regulate its function so that the floor seems flat in keeping with observed.
Step 2. Put total station at tripod.
Total station device is positioned at the tripod, secure with a centering screw. Even as pressing the device with the alternative hand, insert the battery with inside the device earlier than leveling.
Step 3. Centering leg tripod.
Centering is carried out through loosening the screw, tightening tripod, and tripod move up, displaying simply above the wooden of the eyepiece plummet.
Step 4. Adjustment of air bubble.
Perform adjustment of air bubbles. This adjustment is supposed to place the air bubbles with inside the center of the tube course in any path proven through the binoculars.
Step 5. Leveling foot screws.
Horizontal clamp and flip the device till plate stage is parallel to two of the leveling foot screws. Center the bubble the use of the leveling screws. The bubble movement closer to the screw. This is became clockwise.
Step 6. Rotate device.
Rotate the device 90 stage and stage the use of the third leveling screw.
Step 7. Observe the survey factor.
Observe the survey factor with insight, the optical plummet, and center the factor through loosening the centering screw and sliding the whole device.
Stage 8. Performing the plate stage bubble.
After retightening the centering screw, take a look to make sure the plate stage bubble in stage is numerous directions.
Step 9. Maintaining the on button.
Turn at the device through urgent and maintaining the on button. Adjust the foot stage screw to exactly center the electronic bubble. Rotate the device 90 stage and repeat.
Step 10. Point telescope to goal.
Release the horizontal and vertical clamp and factor the telescope to a featureless-like background. Adjust the reticle attention adjustment till the reticle photograph is sharply focused. Point telescope to goal and regulate the focal telescope to goal and regulate the focus point ring till the goal is focused.
Step 11. Repeat the procedure.
Repeat the procedure at the prism step up and station 1 and 3.
Process 3, 4, 5 method.
Once the location of the constructing wall is marked, motion have to be taken to preserve those symptoms. The spikes are set up across the constructing line with a distance of as minimum 1.2 meters from that line. Next, determine the location of boundary stones and make certain the course of the constructing. After that, determine the location of the primary constructing line through measuring from the stone border. Then roll the two corners of the constructing factors A and B. They are marked on the road, the primary to the use of wood spikes measuring 50mm times 50mm times 300mm. The precise row of the corners of this constructing is marked at the spikes at factor A and B. Above the road, AB plant a spike at F at a distance of 3 meters from A and nails in this spike row precisely 3 meters from A. Next is to find the location of E with the measuring tape pulling from A and F in order that its distance is exactly 4 meters from A and 5 meters from F. This attitude of EAF is precisely 90 degrees, primarily based on right angle triangles, which are 3, 4, and 5. The row of factor T turn into located through following AB and measure with a tape gauge. The row of factor C may be received with a measuring tape pulling from D and B in keeping with the measurements of DC and CB. The spikes are blended and the C row is sufficiently nailed.
So here is our illustration of complete setting up. That's all from us. Thank you.